Welcome back to the Ultimate System Design course, where you get the opportunity to learn from someone who's already built and scaled systems. I'm Akhil Sharma, founder at Armor AI, which is a cybersecurity startup backed by Techstars and Outlier Ventures. In this video, we will talk about the real-world inspirations for system design, or how system design came into existence. See, everything in the software world, directly or indirectly, gets inspired from the real world. The innovations in the processes being followed at automobile manufacturing plants led to innovations such as Kanban, Lean methodology, and Scrum that we all follow today. You will find traces of this in the innovations done by Toyota in the 80s and 90s. Similarly, the way isolation and containerization of packages has been done in the shipping industry for making transport more efficient, well, that ended up inspiring the containerization and container orchestration revolution in the software world with Docker and Kubernetes. Similarly, we can find many instances in the real world that ended up inspiring system design in the software world. Let's understand this with a few examples. I'm sure we've all been to an overcrowded parking lot and thought to ourselves that, hey, this could have been designed a little better. Well, designing parking lots is actually a great system design problem, because you need to have multiple exits and entries, you need to make sure that there are no bottlenecks, and it should have multiple alternative routes so that if there's a bottleneck, other cars can avoid it. It should also be able to handle more traffic than usual. So designing parking lots takes a lot of planning and a deep understanding about the problem. Similarly, in restaurants, there are multiple chefs, so that even if one is not feeling well, the kitchen can still function. The recipes in the restaurants are repeatable and the processes are already set. So it's not dependent on one chef to create a great dish. And all of the chefs can do it equally well. So if you think about it, good system design is actually critical for good business practices. And this is where technology and business coincide. A good system design ensures that the establishment functions properly. While in this course, we're going to limit ourselves with software-related system design concepts only because they're quite complex and extensive. But it's great to know that the same rules apply everywhere else and not just to software. Let's take one final example of gas distribution pipelines. These are super complex systems because there's a central gas agency and the gas is distributed to multiple individual homes via pipelines. Now that means that the pipeline needs to be laid out in such a way so as to minimize failure. If one individual home's connection gets affected, it should not affect the connections at other homes. Also, the tolerance of failure is extremely low because it's hazardous and mistakes can prove to be fatal. There need to be alternative routes for each pipeline, and there needs to be parallelization and replication so that if one pipeline fails, the gas can be routed through others. There need to be threat monitoring systems so that we can observe the issues that may happen in the future and they can be fixed as they take place. There also needs to be a sophisticated failure recovery mechanism so that even if the systems go offline, they can still be brought back online. And the systems need to be easily maintainable and extensible, meaning that you can easily fix them or extend the pipeline to add new homes to the grid. Now we will dig down into concepts like extensibility and maintainability in some of the future videos, but it's good to have a preliminary knowledge of what these are. Looking at these three examples, we've observed one very critical thing, which is the fact that we're not depending on the inefficiencies of people and human-related errors. Instead, we're focusing on building a great foundation for an intelligent system where the system can tolerate and also recover from failure. And that's the core crux of system design. We're essentially creating systems that can function well without any human intervention. And we're thinking about mechanisms where systems can recalibrate and even refine over time. And real-world systems, just like software systems, have the same challenges with scaling, failure, handling failure, and recovery from failures. In fact, anywhere you're having to think about these details, you're probably designing a more effective system. Now, there's a reason why I went through those three specific examples: restaurants, gas pipelines, and parking lots. Because even in software system design interviews, the interviewer might ask you to design a restaurant instead of a food delivery app, or a parking lot instead of a ride-sharing app. And you, as a software engineer, might end up getting very confused, and you might think, what's the connection between a restaurant or a parking lot with actual software? But after watching this video, you have way more clarity, and you understand that system design doesn't exist in isolation. In the next video, we'll understand the difference between high-level system design and low-level system design. So see you in the next video.